Hello again. So in answering a student's question earlier today about 1 through 4 on the homework, I realized that I didn't address something on the notes. So I'm going to go ahead and do that right now, and I created two problems similar to 1 through 4 so that I could answer those questions with you, okay? So um, in the notes, I did address, like if I gave you tangent of an angle and then you found that it was half of this angle, then you knew what the sine was, or sine or cos, like the sine, the cosine, the tangent, what the value was. Was it positive or was it negative? But what I didn't address is whenever I just gave it to you kind of in random. So let's talk about this. If I have some angle in the first quadrant, right? Some theta, and then I ask you to find sine of half of that angle, right? Well, whatever angle this is in the first quadrant, the most it could be is 90, and technically it wouldn't even be in the first quadrant then. And anything half of that is a number between 0 and 90. And so sine, cosine, and tangent, all of those would be positive. And you do have to worry about that on sine and cosine. Tangent, you only have to worry about it if you use this form, but that's not the one I suggest you use. I suggest you use these, and then it just kind of falls into your lap anyway. Cool? So really, we're just looking at the sine and the cosine. So let's talk about in the second quadrant. If I have an angle in the second quadrant, some angle, right? The most it could be, and honestly, I'm not talking about this, but so much as like this angle, because I said, hey, an angle between pi, or pi over 2 and pi. Well, let's think about these in degrees. So that's 180 degrees and that's 90 degrees, right? If I were to take half of 180 degrees, the most an angle that could be still in here is 180. It would still be 90, right? So say I picked 160 degrees. If this angle was 160 degrees, and that put me in the second quadrant, well, half of that is 80, and 80 is over here, right? Any angle between these two angles, 90 and 180, is going to be a number less than 90, which means everything is still positive. So sine of the half angle and cosine of the half angle are both positive, okay? Because any angle between 90 and 180, if I cut it in half, any angle between these two, right? So 179, 178, 92, they're all going to be numbers between 45 and 90. Because half of 90 is 45, and that's the smallest, it would have to be one greater than that, or point something greater than that. So let's talk about the third quadrant, because that's where it gets a little bit more interesting. So say I have a triangle in the third quadrant. Well, this is 270 degrees, and this is 180 degrees, right? If I cut 180 degrees in half, I would get 90 degrees. And if I cut 270 in half, I get 135 degrees, which is halfway in between here, right? So 135 degrees, which means any angle in this quadrant that if I cut it in half, it's going to land somewhere in this sector. Okay? Because half of the smallest it could be, 180, so 181, it's going to be greater than 90. But half of this is going to be 135 maximum. So anything that we have over here, if it's theta over here, then half of that is going to be in here. Okay? So when I pick any angle in that little piece right there, any of those right there, right? In all of these cases, I'm going left and I'm going up. So sine of a half angle that I'm going up would be positive, the positive square root. But because I'm going left, cosine of the half angle would be negative. So if I'm in the third quadrant with theta, and then I cut it in half, then I'm going to end up somewhere in the second quadrant, which means cosine would be negative, but sine would be positive. Okay? So one more. If I take a triangle in this quadrant, and I'm between 360 and 270 degrees, yeah? Well, half of 270 degrees, we already said, is 135. And half of 360 is 180. So if I'm in the fourth quadrant with theta, then half of that, at maximum, is 180. At minimum is 135, because half of 270, right? So any angle between 270 and 360, if I cut it in half, it's going to land somewhere in here. So again, we're going left and we're going up. Sine is still going to be positive, and cosine, it's too bad you can't see that, and cosine of the half angle is going to be negative. Okay? Which means no matter the angle, if it's in between 0 and 360, the sine's always going to be positive. Now, if I go outside of 360, then you run into a little bit more interesting situations. So, let's talk about these right here. Okay? And I'll circle back to that at the end just to make sure that we're clear, and I'll flip it over and do some examples, okay? Well, I guess I might go ahead and do that now. So, if I told you that theta was, yeah, let's do whatever. So say theta was 120. Yeah. Half of that is 60. So even though if 120 degrees cosine is negative and sine is positive, half of that is going to be in the first quadrant, so both sine and cosine are positive. Okay? Say it was 180. So let's go with 240. So right here. That should have lined up with that one, but oh well. So 240 degrees, right? 240 degrees, both cosine and sine are negative, but you cut that in half and you get 120. In which case, cosine is negative, but now sine's positive. Yeah? And again, if I pick, like, say, 300. If I go 300 degrees, but then I cut that in half, half of 300 degrees is only 150. So that puts me in here. And again, cosine is negative, sine is positive. All right? Now, when it can be a little bit more interesting is, say you're in, let's see, this is 360. Say I said it's 380 degrees, right? So it's a full rotation plus 20 more. 380 degrees. Now, half of 380 is going to be 190. So that's 190 degrees. That puts me in here. 190 degrees. So whereas 380 degrees, everything is positive, left and, we're going right and we're going up, cosine and sine. 190 degrees, it's in this location, both the x, the cosine, and the sine would be negative. So that's where it gets a little bit more interesting. Okay? I hope that helps a little bit. And then when I do these examples, maybe we'll solidify it. So on this one, I said sine of theta equals 14/4, where theta is between pi over 2 and pi. So pi over 2 is at the top of the unit circle, and pi is over here. So we are in the second quadrant. So I'm going to draw a triangle in the second quadrant. And I know sine is square root of 14 over 14, or square root of 14 over 4, so I'm going to put square root of 14 over 4. So opposite and hypotenuse. And the question was, what is sine of half that? Right? So sine, my half angle formula for sine is plus or minus the square root of 1 minus cosine of theta divided by 2. Well, that means I do need cosine, and I do need to figure out if it's sine or if it's positive or negative. So sine of half of this angle. So this angle is somewhere between 90 and 180 degrees. So if I pick any number between 90 and 180 degrees, half of 90 is 45, and half of 180 is 90. So half of this angle is somewhere in here. If I'm in the first quadrant, that means both left and, both horizontal and vertical are positive. So we are definitely dealing with the positive. So this is going to be positive square root of 1 minus the cosine over 2. But in order to figure out the cosine, I need to know what this side is, right? So I'm going to go, I don't know why I just do that, but whatever. A squared plus b squared, so square root of 14 squared plus b squared equals 4 squared. So I've got 14 plus b squared equals 16. B squared equals 2, b equals the square root of 2. Now I'm going to put the square root of 2 over here, but I'm going to remember, I am in this quadrant. So for theta, this is negative, okay? Which means inside here, for cosine of theta, when I have adjacent over hypotenuse, I'm going to say negative square root of 2 over 4. Cool? So now I have, let's see, the square root of 1 plus the square root of 2 divided by 4, all divided by 2, which is divided by 1. I'm going to do a common denominator, so I'm going to make this 4 over 4. I'm going to combine this to say the square root of 4 plus the square root of 2 over 4, and then I'm going to flip and multiply by the reciprocal of the denominator. And that's going to be the square root of 4 plus the square root of 2 over 8. Technically, we could split that up. Do I need you to? Nah, you can just leave it. Call it good. Okay. And so then that would be our answer. Just if sine of any angle is square root of 14 over 4 in this quadrant, then sine of half of that angle, whatever it is, would be this value right here. Okay? In case you are interested in how we would simplify that, because I know you're all just dying. Well, I wouldn't do that. I would do square root of 4 plus the square root of 2 over the square root of 8, and the square root of 8 is 2 root 2. And then I think I'd multiply top and bottom by square root of 2, which is kind of interesting, because then you've got the square root of this times the square root of that. So, okay, to be clear, the square root of 4 plus the square root of 2 times the square root of 2 is the same thing as 4 plus the square root of 2 to the 1/2 times 2 to the 1/2, which is the same thing as 4 plus the square root of 2 times 2 all to the 1/2. I want to make sure that you understand we're not going to distribute a square root of 2. We're going to distribute a 2, because the square root is the part that they combine underneath. So that would be 8 plus 2 root 2 underneath the square root. So it would be the square root of 8 plus 2 root 2, all divided by the denominator, which is going to be 2 times 2, and that would be 4. Anyway, just for your information, but this one's good. Okay, let's do this one real quick. So tangent, I've got in the fourth quadrant. Okay, so if I'm in the fourth quadrant with theta, and tangent is opposite over adjacent, so I'm going to put opposite and adjacent, and the negative has to go to the 4 because it's going down vertically as opposed to the adjacent, which is going horizontally to the right. Okay, let's talk about cosine. I need cosine of theta divided by 2. Cosine is plus or minus the square root of 1 plus cosine all divided by 2. So that equals plus or minus the square root of 1 plus cosine of the angle divided by 2. This is a 3, 4, 5 triangle, so I'm going to go ahead and label this side as 5, the hypotenuse. And I've got to decide whether or not it's positive or negative. Well, so I'm in this quadrant, right? The maximum I would be is something below 360, and the minimum I would be is something right above 270, right? So if I pick any number between 270 and 360, half of 270 is 135, which puts me halfway through this quadrant, and half of 360 is 180. So half of this angle, this entire angle, would be somewhere in this quadrant right here. Okay? Or this quarter of a quadrant. Or half of a quadrant. That was bad. Okay. Which means I'm going to end up with my answer being some kind of go to the left, go up to the right. The cosine of it would be negative over positive. And so we use the negative. Okay? So remember, anything in this quadrant, if I were to take half of that, the cosine of it would end up in here, or the angle would end up here, half of that, and cosine of anything in this quadrant, it would be negative. Now sine would be positive, even though sine is negative over here. It would be positive up there. Because remember, the goal is to find cosine of half the angle, not cosine of the angle, because cosine of the angle would be 3 over 5. Okay, so I've got the square root of 1 plus divided by 2. I need cosine of theta. Cosine is adjacent over hypotenuse, so I'm going to use that, the cosine of the angle. And then I'm going to do common denominator. I'm going to make that 1 a 5 over 5. So I've got 5 plus 3 over 5 times the reciprocal, which is 1/2, and that's an 8. And 8 divided by 2 is 4. So I've got the square root of 4/5, which I think I would hope that you would see that that's 2 over the square root of 5, which means final answer 2 root 5 over 5. Cool. Yeah. Okay. I hope that helps as far as like figuring out the sign goes on the plus and the minus. As far as this goes, remember if it's anywhere on the with 0 to 360 or 0 to 2 pi, in all cases we end up in the top half when you cut them in half, because half of 360 is at most 180. Well, half of 360 is 180. So the most you could be is something close to 360, which means the most you could be is something close to 180. Sign is always positive in the first and second quadrants, so the only thing you got to worry about is cosine, the sign of cosine, right? And if you start out in this quadrant or this quadrant, then know that half of that is going to end up in this quadrant where cosine is negative. And there you go. Okay. I hope that helps. You don't have to worry about the sign on tangent, because tangent, the sign will appear naturally unless you use this one, in which case you do have to think it out. Okay. Bye, guys.